Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at OMICRON, and I will be your host. Hello, everyone. Investments into medium voltage grids are growing fast, and so are the testing demands that need to be covered by the operators. During commissioning and maintenance testing of medium voltage switchgear, protection engineers have to perform a whole range of tests to ensure the correct operation of the equipment. In general, several test sets are needed to cover all necessary tests. In this episode, OMICRON switchgear testing experts Gerd Kaufmann and Fabian Kolb give us a comprehensive overview of how multifunctional test sets can boost testing efficiency on medium voltage switchgear. Gerd and Fabian highlight the importance of medium voltage switchgear and the necessity of rigorous testing to ensure reliable operation. They emphasize the need for skilled personnel and advanced testing tools to manage the increasing complexity of modern electrical systems. Gerd and Fabian describe the differences between commissioning and maintenance and tell us about the testing challenges faced by field engineers. They also explain the benefits of using multifunctional test sets like OMICRON CMC 500 and the role of automation for enhancing testing efficiency. So without further delay, I welcome Gerd and Fabian to this episode of Energy Talks to give us their insights into this topic. Thank you both for joining me.
Hi, Scott. Thanks for having us.
With pleasure, Scott.
Well, thank you again for being here to talk about the benefits of using a multifunctional test set in medium voltage grids. Could you describe the current developments and future trends in power distribution grids?
Yeah, so let me start here. So the current status of the distribution grid, what we are observing is a significant transformation, what I would say, or a change in the electrical energy landscape. The distribution grid used to be designed for what we would say unidirectional power flow from a large generation plant to the consumers. And now it's a little bit different, and we need to accommodate still increasing number of renewable energy resources and new kinds of load. So that means we need to reevaluate the grid planning, maybe also the grid operation, and in relation to that, the protection strategies. So the distribution grid now is more what I would say a dynamic, intelligent network. We have really a large integration of decentralized renewables like solar and wind. And these mentioned new kind of loads such as heat pumps and electrical cars. And this is all increasing the complexity and the dynamic in the distribution grid.
Thank you, Gerd. That sounds like a lot of change that affects the grid operator.
Yeah, it is definitely, Scott. So a lot of change means things like fast grid expansion or even modernization. So that is linked to a lot of or high investment in the distribution grid. And these investments have increased significantly in the last years. As an example, they are investing in things like intelligent ring main units or intelligent secondary substation to gain more information of the grid. So to handle situations like a changed power flow and so on better, to control the grid better. And then that leads to more and more assets being brought into the grid with more features. And that, on the other hand, what is maybe good for us, means also more testing to ensure a reliable grid operation, because no one wants to be with a blackout.
Definitely. What kind of challenges are associated with this development, especially with the expansion in distribution grids?
First, there is the sheer scale of new installations because of this change in the distribution grid. And all this new installation has to be tested during commissioning and also maintained over the whole life cycle. And this leads me to the second major challenge for the grid operators. There is I would say, a global phenomena for parties in the energy sector that there is a workforce limitations. That means we need personnel to carry out those work safely. So companies in the energy sector are struggling to find skilled and qualified engineers or technicians to carry out this kind of work. And if we talk about expanding the grid, also the human resources are needed to keeping up the pace to perform this kind of transformation of the distribution grid.
Thank you, Fabian. Gerd, is there anything that you would like to add?
Yes, Scott. I would like to talk about already mentioned increased complexity. So the assets like a modern medium voltage switchgear is getting more and more smart and sort of an integrated system. So what we have here is digital communication. We have digital protection devices. We have also combined control and protection devices. And together with that, there comes automation and the interface to the automation and control center. And all of that means testing such a complex system in a modern medium voltage switchgear. And this requires more and more attention and expertise, as Fabian has mentioned, and more advanced test tools.
Okay. So what is so special about medium voltage switchgear? Can you explain?
Yeah. So medium voltage switchgear is a critical and very important component in the distribution grid. On the one hand, we have the transmission grid, and the medium voltage switchgear is acting like an interface from the transmission grid to the local distribution system. The typical used voltage level for medium voltage switchgears are starting from 1 kV up to 50, 60, 70 kV. It strongly depends on the region and how you define a distribution system. What it makes it really unique is that a medium voltage switchgear contains a lot of functions and a lot of assets in one cubicle.
Interesting. Thank you, Fabian. Gerd, did you want to say something to that?
Yeah, I just want to confirm what Fabian said. The last point, so the assets or the things that we have included in the medium voltage switchgear are like the CTs, so current transformers, voltage transformers sometimes. We have protection relays in case of a circuit breaker that is used in the medium voltage switchgear. We do have disconnectors, and all of that together with communication to the remote control center. And some of these units even support automated grid restoration. So in case of what I would say, very unlikely blackout.
Could you provide an overview of the types of tests required during the commissioning and maintenance of medium voltage switchgears? Is the list of required tests the same for commissioning and maintenance?
First of all, let us split these two questions. Starting with the first one, let me try to take you through a journey of testing, a typical testing workflow of a medium voltage switchgear. We normally start with a wiring check. In my point of view, wiring checks are often underestimated. Even my personal experience has shown that brand new medium voltage switchgears often contain wiring errors. And finding wiring errors in a later stage can result that all tests are obsolete and you have to carry out all tests again. You can even simplify wiring checks with primary injection. So that means you are testing from the source, most probably the CT, to the destination. In that case, for instance, a protection relay.
Okay, great. Thank you, Fabian.
When we stick to the CT, Fabian would like to do a wiring check. I would like to do the CT test or test the CT itself. And if we test the CT, we also would like to test the VT. What would we test? The test would be the ratio, so CT ratio, current transformer ratio, and voltage transformer ratio. And for current transformer, it's especially important to make sure that the CT, because sometimes they can have two cores, one is meant for the protection relay and the other one is meant for the metering, that we would like to connect the protection device to this protection core of the CT. And this is usually figured out by testing the knee point voltage. This is one thing, to differentiate between the protection core and the measurement core. And the other thing is, especially valid for the metering, is the burden of the CT to have the right operation range of the CT, to have an accurate measurement, or for the protection core, it is, do we reach the limit of the current transformer to transmit the whole current that we would like to see. So this is for the conventional CT, what I would say. And there's, of course, a trend going into something that's called non-conventional CTs. They are called low-power instrument transformers, and they are becoming more and more popular. So this requires different test signals, because imagine the current from the primary side is converted into a voltage signal, like millivolts. You can imagine maybe things like a Rogowski coil to measure that. So, and these signals are usually very small and very sensitive. So it is important to verify the integrity of the signal and the compatibility with the protection relay, so that really the millivolt signal is read correctly in the protection device.
Let me pick up here again. Once the instrument transformers are checked or verified, the next logical step is, of course, the protection relay, regardless if it's connected to an LPIT or conventional CTs. Typical protection functions used in medium voltage grids or distribution grids are, I would say, overcurrent elements, could be directional or non-directional, voltage elements or frequency protection. But also here in distribution grids, we have huge variety depending on which place we are on Earth. To finalize the whole fault clearing system, we end up with the circuit breaker. Also, the circuit breaker is a really important asset in this fault clearing chain. The circuit breaker has the ability to switch off fault currents to protect assets or people against electrical hazards. What can be tested on circuit breakers? A very important test there is the live trip test. So there you can check the reaction time of the circuit breaker. Also, depending on the architecture of the circuit breaker, you can also perform other tests like the switching pole synchronism if the main contacts are available, for instance. You can also complete the test with checking the motor current or even the coil current.
We were talking now about the chain from the CT, protection device, and the circuit breaker. And then it's, again, the communication. So not to forget the communication to the remote control center. And that means regardless of the used protocol, in different countries you will see different protocols like DNP 3.0, IC61850, for example. So we would like to make sure that all the signals are being sent to the remote control center, and vice versa. The commands for tripping circuit breaker, switching on or off, are also received properly. And so all of this, if this is all tested, and if something goes wrong, we are automatically in the situation of troubleshooting. And this is also something that should be done during commissioning. And this is something that's hopefully not happening just being discovered during maintenance work.
Let me pick up your question again, Scott. You asked in the beginning if there is a difference between commissioning and maintenance. I would say there is definitely a difference, but there is also an overlapping. If you talk about commissioning, we can, let me try to summarize in one sentence what commissioning is. So during commissioning, we verify the new installed equipment and we are checking if it's correctly configured, if it's correctly wired, if it's functioning before we energize the whole system for the first time. We ensure that the system is safe and ready for operation. It's like a comprehensive one-time validation. If you compare that to maintenance, maintenance is a more periodic testing and inspection of equipment which is already in service. You want to make sure within maintenance if the system is running continuously safe and reliable. And if you compare that on different kind of measurements and tests performed, during maintenance, the tests are often more functional, and because this is more than sufficient for maintenance. But it also depends on legal aspects. Maybe there's, because of some compliance or laws, more comprehensive testing is required during maintenance. But it could also be beneficial to perform tests done during commissioning while maintenance. One example would be you can measure the coil current during maintenance as well and compare the results with commissioning. Then you can see if there is a change over the time, for instance.
What is essential to be able to perform all of these tests?
Yeah, if we start again at the beginning at the CT and maybe also the circuit breaker, we would like to perform maybe primary injection. So first thing what is coming to my mind is a powerful current that we can provide with a test kit. And if you think about protection, then most of the time voltage measurement comes into the picture because it's a directional protection function, like directional overcurrent protection or distance protection. So we would like to have some voltage outputs as well. So that's quite obvious, I would say. And on the other hand, we need to read back all these signals that are being generated by the protection relay. So we need some binary inputs to read it back. And these binary inputs should be ready to trigger on maybe DC signals or AC signals as well. And to trigger something else, like an extra protection relay, we need some binary outputs as well. That's what first comes to my mind. And maybe Fabian has another idea and can add something here.
Speaking about protection testing, I think you mentioned all the hardware-related stuff already. But if we talk about protection relay testing, we also have to talk about a software tool which provides the ability to define, execute, and in best case, reuse test templates. There is a simple example for that, for reusing test templates, especially during commissioning. Imagine you have a lot of feeders to commissioning, and all these feeders have slightly different protection relay settings. Wouldn't it be beneficial to have automatically adjusted test templates? If you ask me, I would say yes, especially if you compare that with manual testing of protection relays.
Okay, so when I then focus on commissioning, then I doubt that everything works well or works out fine from the beginning. So I'm always also thinking about troubleshooting. And for troubleshooting, I think about analog inputs that could be useful to measure something, to measure things like currents, voltages. So in the minimum, to analyze the signal quality, what do we have? What do we get back maybe from the measurement? Or if you think about transformer protection, for example, in a substation, then you might measure inrush currents of transformer to see if the protection setting is okay or not. And then what you said, Fabian, about the circuit breaker testing, we would maybe like to measure the circuit breaker current for the motor coil to measure that as well. So I see that analog inputs are very beneficial here.
And that's right. I would like to add something else here. If we have a look at the medium voltage switchgear, also the technologies involving in medium voltage switchgears. Gerd, you already mentioned these low power instrument transformers, LPITs, are getting more and more important, and they are used instead of conventional current transformers because of their benefits like small size, cheaper, safer, and so on. But also what we can see is a trend going towards to digital protocols like IC6150. So what is already in place is, for instance, that Goose is used for interlocking schemes, for instance. To summarize it all, in best case, everything would be combined in one multifunctional test set.
What role does automation play, for example, in the testing process when using multifunctional test sets?
Yeah, I mean, for me, it's one of the key features, because if you think about this whole thing, it's very complex. And then I think especially about the protection relay, again, that might have multiple functions. Their automation means for me having test templates. So that can be, we would like to repeat a single step over and over again, or we would like to have a complete test routine, test procedure that can be automated. So just imagine, simple example, we have a combined test template for testing the overcurrent protection and the distant protection as well. That has several benefits. I can use it in the same commissioning. There won't be only just one feeder that has to be tested. There's another one and another one. I can reuse that for the commissioning. And then later during maintenance work, I can reuse it again. So that there are multiple benefits for automation here.
Yeah, I fully agree. And I think those templates can be specific. That means you can have special relay manufacturer. You have a special relay template which completely fulfill all the tests which are, or all the protection functions which are configured in there. But also it could be generic templates, for instance, used for DR applications or even for multifunctional protection relays, because they also have the possibility nowadays to parameterize whatever protection function you want in there. So it might make sense to use generic templates. Anyhow, there are other benefits related to test templates in my point of view. If you talk about automation, we also talk about the possibility to minimize the risk of human errors, especially if you compare that stuff with manual testing. Additionally, you of course increase your efficiency. Of course, not at first glance, you have high initial effort, but on the long run, the return of time investment is very, very beneficial because you can just easily repeat all the used test templates. But this also makes me think more about that if I compare it to manual testing where just voltages and current just apply to the relay and manually adjusted. With automated test plans, you also have the reproducibility. You can clearly see how is an element tested. I would say this significantly increase the testing quality.
What are the challenges faced by the test person using such a device?
This is a good question. I think even though it's the protection engineer or the field technician, I think they are often under a lot of pressure. There are a lot of assets inside one medium voltage switchgear cubicle, so the test variety is the right range of tests they should have to conduct during commissioning or maintenance. They can start from visual inspection to performing different kind of measurements on different kind of assets. And this all in a rather short of times and sometimes in tough field conditions.
Exactly. One of the biggest challenges as well for them is the increasing complexity. Fabian mentioned the time, I'm mentioning the complexity. We have the digital relay, we have communication interfaces, we do have automation at the other hand, and then not to forget aspects like cybersecurity. This is a wide range what they have to consider. So the test person needs, just remember the CT and VT stuff, needs to know the traditional electrical testing on one hand, and also needs to know the modern digital communication protocols such as IC60150 and consider that and bring that all together somehow. So that's really challenging.
Yeah, fully agree. And regarding this new technology used in medium voltage switchgear and these variety of tests and these interfaces you mentioned, Gerd, I think it makes it really hard for the field technician to be up to date, to keep up all the knowledge. And there is a knowledge gap for some field engineer. And because there's also, due to this transformation of the distribution grid, we also see that they need to install as many as possible. So that means this is a high time pressure for the field technicians. So just imagine, testing is the last step down before energizing or the system or bringing it back to service after maintenance. It's always the last time. So the time window is rather small. And I think it's tough to keep the balance between being fast and getting the job done professionally.
Yeah, so to sum it all together somehow, they have to be quick. So ideally in one day, they're able to perform things like wiring checks, protection testing, communication testing, maybe troubleshooting if something goes wrong. And last but not least, and maybe most important, they need to document all those things. So this is really essential. So tools, in my opinion, that reduce possible errors is essential. They can actually focus on what really matters. And maybe if they have just one tool, yeah, and not multiple tools for one thing. That's why we talk about multifunctional test set. So if they have a tool that supports all that, they can focus on their work and they don't need to take care of a fleet of test tools they need to manage. So that helps also, in my opinion, to reduce mental load for them, a little bit stress relief. And at the end, it's a benefit for all of us. It ensures a reliable distribution grid.
What kind of benefits do you see in using a multifunctional test set?
Yeah, I can think of many. So we have seen, I think, the increased efficiency. We have a single device to perform different tests on different assets in a medium voltage switchgear. You remember what was mentioned, the CT, the circuit breaker, protection relays, troubleshooting. And again, it's less devices to carry around. And then at the end, it saves time.
Yeah, and this, for me, it's easy math. That means all that translates into cost savings. That means, for instance, the logistic and maintenance. You have only one device to calibrate regularly. So this fleet management, it's not like handling 3 devices from 3 different manufacturers. I think this makes it more easy. And another big benefit, especially if you lack skilled workforce nowadays, is that you have to train your team only on one device and only on one software environment. I think this is a really huge benefit.
Mm-hmm. And because of all that, what Fabian also mentioned, I can see that the quality of the testing might increase. And because we are not only testing, like in the past, maybe the protection relay, we do test the whole chain just by one person, and there's no misinterpretation maybe between two people in the testing field. So that's another benefit, what I see by testing the whole chain.
And let's not forget the flexibility. That means we already talked about the technology development in medium voltage switchgears, starting just having electromechanical components until we have, for instance, using digital interfaces like IC6150 or LPIT. With one device, you can test different kind of, I would say, it doesn't matter which step of evolution of medium voltage switchgear, you're ready to test. I think this is also high benefit of flexible multifunctional test set.
So does OMICRON offer such a multifunctional solution?
Of course we do. Else we wouldn't talk about it today. So we just have released the CMC 500, which is our latest generation of a multifunctional test set. So, and it's designed especially for these evolving needs in the medium voltage grid and in the industrial applications.
Could you describe the new OMICRON CMC 500 and its use as a multifunctional test set for this and other applications?
At the analog side of the chain, so CT and VT, we might need to support several currents. So the CMC 500 can be equipped with up to 10 current channels. And on the other hand, it's also supporting up to 7 voltage channels. So that enables you to test complex protection setups. If you think about a 3-winding transformer, maybe a differential protection of a 3-winding transformer, so you have on each of the windings 3 currents that you need to test. So that's with 10, 3 times 3, we need 9 currents, so 10 current channels would be sufficient for that. Or we would like to connect these current channels maybe in parallel to gain a higher current. So this is also possible. The CMC 500, you can generate 3 times 150 amps, so which is, fair enough to have a primary injection already with 3-phase signal. And then if this is not enough, you can still connect these 3 currents in parallel to have a single-phase current of 450 amps, which is more than enough to have a primary injection and also maybe making a primary test of a circuit breaker.
Yeah, and to round it up, it also comes with the classical tools. You may be aware with the classical CMCs we have available. So on the one hand, we have Test Universe. For me, it's the established standard in protection testing. We were talking about templates. So there is no need to start from scratch. There's also possibility to use one of the 550 templates we provide. And these are available, designed from engineers and tested by engineers. So I would say you can trust them. And if we have a broader look, we can also have a look at relay sim tests, especially for medium voltage or distribution grids. Maybe there is also the possibility to test transient protection functions rather easily with relay sim tests, or there's also CMC Swift available for wiring checks. We have Analyzer available where we make use of these multifunctional inputs. And Gerd already mentioned several times where we can use these multifunctional inputs. And with the CMC 500, we have the possibility to measure those signals and create files out of that. So I would say it's a perfect tool for troubleshooting. And even if you are not yet using IC6150, the CMC 500 is ready for the IC6150 environment, supports process bus with sampled values. You can test GOOS, MMS, everything is supported here. And also for LPIT testing, that does not mean we just perform testing with primary injection. You can also really simulate with an accessory the LPIT low-level signals with the CMC 500. So to round it up, I think the CMC 500 was designed with the field engineer in mind. It's lightweight and rugged.
What other characteristics does the CMC 500 offer users to make testing easier, safer, and more efficient in the field?
If we look a little bit in the future, with the CMC 500, it is soon possible to perform CT checks on current transformers. So this software is called CMC CT check, and it has its benefits. So it's not done with primary injection, it's done with secondary injection. So it's easily possible now to check if the relay is really connected to the protection core or the measurement core.
What other characteristics does the CMC 500 offer users to make testing easier, safer, and more efficient in the field?
Yeah, there I have a specific example. So with the CMC 500, it's soon possible to perform t-tests, not only with primary injection, only also with secondary injection. So you can easily check beside the ratio polarity, the burden. You can also check the winding resistance and the knee point voltage. And this knee point voltage, already mentioned by Gerd, is needed to check if the protection relay is really connected to the right core. Additionally, there are some benefits with the secondary injection. Of course, you have less wiring effort. A lot of cables can be removed. You have a single page report then in the future. And additionally, we have a guided workflow and also with safety guidance.
Okay, so let me continue here because he was talking about safety. Because your question was also about safety benefits of the new CMC 500. So there's a special focus was put on the safety requirements of the CMC 500. So there's a separate button to arm or disarm the device, to put it in a safe mode or in an active mode. So you decide when you would like to output something from the device. And just imagine you would like to rewire something. You were finishing your work on feeder number 1 and you would like to continue at feeder number 2. You don't need to rewire the CMC 500 side, you just need to rewire the feeder side. So you put the device into a safe mode. All the current and voltage outputs are being short-circuited, so no high voltage or dangerous signal can be there anymore for the user. So that's one thing. And then also to prevent unauthorized usage, I would call it, there's an interlock key in the device, and there will be a break because you are not working 24 hours, and there will be a lunch break, obviously. So you can take out this interlock key, and so that no one else can use the CMC 500. You can leave your wires as it is and continue after your lunch break very easily. So just to make the whole thing very safe, this whole safety concept is following several standards, international standards. We don't need to go through that here, but just to mention, we put a high focus on this personal safety with the CMC 500.
So where can our listeners get more information about multifunctional testing and the new CMC 500?
I would recommend to Google CMC 500, or maybe for the new generation, you can also search via ChatGPT for the CMC 500, or you directly use our homepage, omicronenergy.com. There you find all the detailed information about the CMC 500, videos, technical data, everything which is needed. But we also host OMICRON events worldwide, so you can also take the opportunity and have live demos, workshops, or conferences, exhibitions, fairs. I don't know. Also there, I would recommend to check our website where we're showing our CMC 500. And you can see the CMC 500 live in action and talk directly with our experts.
Very good. Do we also offer any training courses through our OMICRON Academy?
Yeah, that's what we are doing. So all the, let's say, different protection training courses that you can perform with us, they will also show you the CMC 500. So that's, beside all the legacy devices, we also use the CMC 500 for these kind of tests or trainings.
Well, thank you very much, Gerd and Fabian, for sharing your knowledge and experiences with optimizing testing efficiency with multifunctional test sets like the OMICRON CMC 500 in this episode of Energy Talks.
Thank you very much. It was a pleasure.
With pleasure, Scott. Thanks again.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. OMICRON has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at omicronenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.